Hello guys, this is Lucy, a freelancer of bioinformatics engineer, and I have more than 10,000 hours of analytical experience on microbial study, and I am a master of environment science. There's a lot of analysis we needed to do after qiime2, but there's no much pipeline we can directly use. In the last several years, I helped a lot of undergraduate or PhD students to write code for their study. And I figure out there's some codes is necessary in all studies. And I like to show you that. First is the rarefaction plot. We can use the rarefaction plot to see if sequence depth is enough to observe diversity index. Small slopes indicate that microbial diversity would not increase too much as the sequence depth increase. Before we go to further analysis, it is advised to subsample the abundance table to the same sequence depth to avoid a difference caused by sequence depth. After we subsampling the abundance table, then we can use the result to calculate microbial diversity. Then we can use well-conquest test or other statistical test to see whether there is a significant difference between or among our groups. Next, we use ordination analysis to see if there is overall difference in microbial community composition. There are several kinds of ordination methods, including PCA, PCOA, and MDS. And sometimes people need to label out the sample names, or they just want to create a ellipse to circular the group. And there is also OPLSDA or PLSDA. This is normally used in medical study. Some study also has a side box plot in PC1 or PC2 axis to see their difference and to test the significant difference. And also we can combine ENV fit analysis and ordination analysis. Then maybe we can see if there is some influence of environmental variables to the ordination result. But this is a non-constrained result. And RDA or CCA analysis is a constrained ordination. Environmental variables were taken into consideration during ordination analysis. It is a constrained ordination. Also, we can use WinPlot to see common or unique taxons. And there are also some code we need to use for further analysis, including merging the feature abundance table and the taxonomy information. And also, we want to calculate the relative abundance or get abundance table from different level, including domain, kingdom, class, order, family, genus, etc. And also, maybe you want to calculate some unifract distance, including Bragg-Curtis distance or other distance. You want to pick out the dominant one according to different condition. It is suggested to use a simple stick bar chart to show the community composition. There are a lot of more beautiful ways to show, including calculate the average or the standard error of it. And we also can use a circus plot to visualize the community composition, as well as the Sankey plot. And also we can see some correlation network to indicate a relationship among tags. This is plotted by GPHI. And we can use R to calculate their relationship first, then imported it into GPHI to visualize it. And also there is some parameters we can calculate it to compare different network. We can use network table to calculate ZI and PI values and give them and assign them some roles in the network. And also we can compare the degree distribution in different networks. And heatmap is also popular in illustrating community composition. We can easily observe the difference in community composition from the color. We also can add extra information like the difference test. We can see whether it is a significant change, increase or decrease. And also we can use heatmap to show the correlation among texts or other variables or texts, and also use the ggcore package to plot the mantle test result. If you have 3 groups, you can try ternary plot. The color can be mapped to phylum or can be mapped to the group. We can use the random forest analysis to find biomarkers for our target variables. Our target variables can be continuous or categorical. If our target variable is continuous, then the importance of biomarker can be measured by the mean decrease accuracy or the mean decrease gene value. If our target variable is continuous, then we can use the increase the mean standard error to show the importance. And we can use methylene analysis to study the correlation between species and the other environment variables. In some ecological studies, the beta NTI and the Robb Creek index was used to illustrate the community assembling process. If you have a lot of samples or OTU, it may take a longer time to calculate it. And if you have a strong background, you may try to use the structural equation to dig out the latent inference to the observed values. And now there is also a package called Microbial marker can be used to do live-seq analysis in R or visualize it. If you are interested in this course, you can contact me by email or just leave a message under this video. And after you buy this course, after you meet some problems with example data, it is free to ask for help. If you have problem with your own data to our code, we offer one-time remote assistance by using Zoom or other telesoftware. And we also provide an extra benefit. If you have a chance to visit Mountain Wuyi, Fujian in China, we can provide you a 2-day free accommodation with your order number. And the detailed script content was uploaded at GitHub. Here is some description in Chinese, but you can see clearly based on the name. And now I'd like to show you how easy it is to run above analysis by using our pipeline. Then you can just run from the source. All you need to do is provide an abundance table and a group file, and also modified some script by changing the color. And it is also necessary, you need to change the color set for your own group. It may take several minutes. You just take we can see it only takes 3 minutes. As you can see, we only use 3 minutes to run all the figure we want. So don't hesitate to contact me if you are interested in our course. See you.